what do I need today to create a large language model that is in the same level of capabilities of GPT, let's say 3.5 on 4. So a world-class language model. What do I need if I want to start this today?
So I think as a startup, I would work backwards from what you want to build, what problem you want to solve. And use large language models as one of your tools in your toolkit. Theoretically, you can start with large language models as they are today. I mean, there's many people who are offering large language models. Some of them are open source. I think we just had Llama, the 13 billion parameter version was Apache 2, and now it's open source. Everyone can use it for commercial purposes as well. Falcon, 40 billion, you can use it. You can actually, I mean, do all kinds of things with it.
Again, Falcon was something not built in Silicon Valley, if I remember.
Correct. It's in the Middle East, Abu Dhabi. I mean, no one was actually expecting that to happen, but it happened. And it's possible. I mean, you need resources, though. You need resources to build the language model from scratch.
What resources? What kind of people, what kind of data, and what kind of infrastructure do I need?
That's a good question. So people who, I mean, okay. You need people who understand the data and structure the data. You need people who know how to train, neural systems. But I think it's important to know people who can manage data, people who can build distributed systems in the AI field. I mean, fortunately, we're not starting from scratch. There is plenty recipes out there which we can actually utilize. But people forget how valuable it is to know how to manage data. There is some, I'm not going to name names, but there's some language models which are dramatically huge, and they're not as good as their smaller counterparts. And my opinion is, it's an opinion, I don't have a factual thing about it, the data preparation of GPT-4, for example, or 3.5, I mean, the data was getting attention more than others. And so this is one thing. So again, we're learning from human input. People needing actually to massage the data a certain way so that the LLM works well. That's people and data. Data, as much as you can get. We're talking about trillions of words if it's a text-only language model, for example. It's necessary. When you do that, I mean, I'm talking to some of the engineers and scientists here. If you do that, don't be, be careful about not to kill context, so to say. I mean, sometimes people clean up too much, and then data disappears, and the context disappears with it, just because you think that you are deduping, for example. Be careful with the deduping. For the people, for the infrastructure to train these big models, you need GPUs. I mean, today, NVIDIA is where it is today because of everyone needing their GPUs, right?
How many, Hassan? Do I need 1,000?
Yeah, you need 1,000. You need more thousands than if you can. Yes.
Okay.
You can do it. You can do it with 8.
Okay. And by the way,
it might take you years.
Okay. And these GPUs, this is the A100, cost about 10, 12,000 each. So we're talking about 20, 30 million dollars.
Yeah, I mean,
that's the hardware.
Yeah, but again, I mean, we don't need to exactly. Where is it? Huh? But you don't need to start with that. I mean, as a startup, I don't want you to see necessarily the wall and then see, okay, I can't do that. There's plenty of LLMs out there. Start with refining an LLM. Doesn't need that anymore. One GPU, maybe 8 GPUs, you're doing an incredible job already. Start with that. And then you can expand on it. Again, also, The magic comes in how to structure around that LLM. LLM by itself is nothing unless you have basically like, you know, what prompts you use, what technologies to feed, what signals to feed into it, and so forth. So, I mean, don't start with the LLM. Start with the problem you want to solve and work backwards, and use LLM as part of your tools. There's more tools, and LLMs are not going to be the last cry. I mean, there's going to be more things to come. LLMs are cool today. I don't know how cool they're going to be in 3 or 4 years. Honestly, there is maybe something else coming.
But you send a super important message that I'm trying to repeat if I understand correctly. So from your large experience, you're saying that there is certain things. So it's like every single young researcher, scientist that I met, they want to work on algorithms. And the reality, what you're saying, you didn't mention algo even one time. You said, learn how to manage large infrastructure, learn how to manage data, and look very, very deeply into the data. Did I understand correctly?
100%. I mean, data is basically what defines all the models these days. I mean, with algorithms, there's going to be improvement, one algorithm versus the next one, and so forth. It's going to be more incremental. You have a bigger impact when you select the right data. You're having more impact. I mean, this is definitely the case. Knowing how to manage data, how to manage models. I mean, there used to be something called ML ops, machine learning operations, that as a job. It still exists, and of course, and it should continue. But people start talking about LLM ops, right? There is that concept, basically building operations and management around large language models. And they need it. Large language models are not a solution for everything. I mean, if you want to use LLMs for translation, you know that better than I do. If you want to use LLMs for translation, I mean, it's going to be cost preventative, actually, if you use that by itself. You have to think about it smartly. How do you combine it with smart machine translation? How do you utilize it with the right data, etc., etc.? So there's smarts which is needed on that field, in translation, in speech recognition, in all kinds of applications.